Now we'll see what is meant by electric charge, how to define a charge. I can define an electric charge as a property associated with an object or a particle or any body due to which it is able to produce or experience and both electric and magnetic effects. So, how I can define an electric charge? It is the property associated with the object or any particle due to which it is able to produce as well as experience both electric and magnetic effects. In this charge, we have two types of charges. One is positive charge, the other one is negative charge. So, before going to explain about this positive and negative charges, we will see how an object is charged. We are just dealing with the charged bodies in this chapter. How an object or a particle or any body can be charged. There are different ways in which an object is charged. I can charge a particle by friction, or I can charge a particle by conduction, by induction. In this chapter, we are going to see how an object is charged by friction. What is friction? When two objects are rubbed against each other, that we call it as friction. So, here we will see how an object is charged by friction. This was first observed by a Greek philosopher named Thales in the year in 600 BC. Thales, a Greek philosopher, he was the first person to observe this property. He observed that when an amber is rubbed with fur, this object acquired, that is amber, acquired the property of attracting some light objects like bits of paper. So, he came to know this amber is gaining some charges. That is why it is able to attract some light objects like bits of paper. This was first observed by Thales, a Greek philosopher, in 600 BC. Then, in 17th century, William Gilbert, he observed not only amber rubbed with fur, but also suitable materials, certain materials like glass, ebonite. When these materials etc., when they are rubbed with suitable materials, these objects also acquire the property of absorbing certain materials. This was observed by William Gilbert in the year 17th century. Then, the classification of the positive and negative charges was first observed by, or it was done by, an American scientist named Benjamin Franklin. Benjamin Franklin, he was a person to classify the positive and negative charges. So, this is the history of this frictional electricity. So, first Thales in the year 600 BC, he observed when amber is rubbed with fur, this amber acquired the property of attracting light objects like bits of paper. Then came the scientist William Gilbert in the year 17th century. He told not only amber, but also certain materials like glass, ebonite, etc. also exhibited this property when they are rubbed with suitable materials. Then the classification of positive and negative charges was told by Benjamin Franklin, American scientist. Now, this was the history about your frictional electricity. In this frictional electricity, an object or a body is charged. An object which acquires charges on friction. So, by friction method only we are making an object to be charged. When an object is charged due to friction or by friction, that object we call it as charged body or electrified. That object we call it as charged body or it is said to be electrified. So, when object gets charges due to friction, that object we call it as a charged body or I can say it is said to be electrified. This term was taken from a Greek word meaning electron. This electrified word was taken from a Greek word electron meaning amber. What is the meaning for this Greek word electron? Meaning amber. So, this was the history about your frictional electricity. So, remember this you may be getting this in 1 mark question. Then we will go for the classification of charges. How an object acquires positive charge, and how an object acquires negative charge. So what is actually happening? How an object is charged? When charging, first an atom is an electrically neutral one. That is, number of electrons will be equal to the number of protons in an atom. That is why it is said to be electrically neutral in nature. But when it is rubbed with certain materials, this object, it may lose electrons or it may gain electrons. When it loses electrons, the number of positive charges increases, so that object becomes positively charged one. When an object by friction, when it gains electrons, the number of negative charges in that object becomes more, then I can say that object becomes negatively charged one. First one, positive charge. How an object becomes a positively charged particle and how an object becomes negatively charged particle. First, an object becomes a positively charged particle when it loses electrons. So when an object loses electrons, it is said to be acquire positive charge. When an object gains electrons, it is said to be negatively charged. We will go for the examples for these two types of charges. First, when a glass rod is rubbed with silk cloth, this glass rod becomes positively charged and this silk cloth will become, or it gains, equal amount of negative charge. How much magnitude it is gaining, how much positive magnitude it is gaining, it will be gaining equal amount of negative charge. What that mean? I told you what is meant by positive charge if it loses electrons. That means in this example, that is, when a glass rod is rubbed with silk cloth, this glass rod loses electrons and those electrons are gained by the silk cloth. Since it is losing the electrons, it is said to be positively charged. Since the silk is gaining the electrons, it is said to be negatively charged. We will go for this example, how an object gains or how an object is negatively charged. Very good example for this negatively charged body or particle is when an ebonite rod is rubbed with fur. This ebonite rod will become negatively charged and this fur will become, or it gains equal amount of positive charge. That means when an object becomes negatively charged particle, it has to gain electrons. That means this ebonite rod, when it is rubbed with fur, it gains electrons. That is, it is losing the electrons. The fur is losing the electrons. Because of that only, this ebonite rod gains negatively charged and this fur will become positively charged particle. Whenever an object is charged due to friction, there will be a slight change in its mass. So an electric charge, a stationary charge will not produce electricity. Here, what is actually happening in frictional electricity, or the charges are moving from one object to another object? Definitely not. So what is actually happening when two objects are rubbed against each other? There is a transformation of charges, redistribution of charges take place from one object to another object. Actually, the charges are moving, are transferred from one body to another body. They are not in motion. That is why they are called stationary charges. A stationary charge can produce only electric field, but when a charge is in motion, it produces both electric and magnetic fields. But when a charge is accelerated, it not only produces electric and magnetic fields, but it also emits waves, or it also produces electromagnetic waves. Now we will see only about the stationary charges. In frictional electricity, we are not going to produce electricity because the charges are not moving. The stationary charge produces only electric field. But when a charge is in motion, it produces both electric and magnetic field. So what we have seen so far, we have seen what is meant by electrostatics and what the history of frictional electricity, how an object can be charged. An object can be charged by different methods. By friction, I can charge a body, by conduction and by induction. In this chapter, we are going to see how an object is charged by frictional. But when an object is charged by friction, that electricity we call it as frictional electricity. In frictional electricity, if the charges are at rest, that type of electricity we call it as static electricity. Now, Then two types of charges, one is the positive charge and one is the negative charge. Now a question, when a glass rod is rubbed with silk cloth, can you say what charge the silk cloth gains, positive or negative? When a glass rod is rubbed with silk cloth, can you say what is the charge carried by the silk cloth? Silk gets, correct, negatively charged particle because it is gaining the electrons. So when an object becomes positively charged, if it loses the electrons, it will become a positively charged. When an object becomes negatively charged, when it gains electrons, it will become a negatively charged. Then how I can define the word electric charge? Can you define electric charge? Electric charge is nothing but a property associated with the object or any particle due to which it is able to produce as well as experience both electric and magnetic effects. In this way, I can define an electric charge. Electric charge is a scalar quantity. Its unit is coulomb. Then if you see the properties of electric charge, this electric charge is a scalar quantity and its unit is coulomb. Then we have seen two types of electric charges. Then we will go for the properties. If there are two like charges, already we are familiar with this. Like charges repel or attract. Like charges, will they repel or attract? And what happens if there are two unlike charges? Like charges repel and unlike charges attract each other. This is the property of the charged particle. If there are two like charges, they will repel, and if there are two unlike charges, they will attract. There is a small experimental verification of this. Like charges repel and unlike charges attract. Now, take a charged glass rod. This is a charged glass rod. You take a charged glass rod. We know that when a glass rod is rubbed with silk cloth, what charge it gains? It will become a positively charged rod. You suspend this glass rod, a charged glass rod with a silk cloth, and you just swing it horizontally. You are going to tie it at one end with a silk cloth or a silk thread such that it swings horizontally. It is going to swing horizontally. Then this is experimental verification to prove that like charges repel and unlike charges attract. You bring another charged glass rod towards this glass rod. What it will do? Will they go towards each other or will they repel? Obviously, naturally what will happen? Since this glass rod is having positive charge, I am bringing near another charged glass rod. These two are having like charges, so they will repel against each other. Now, instead of this glass rod, you bring a charged ebonite rod. I am going to bring a charged ebonite rod. We know that when an ebonite rod is charged, what charge it will gain? It will become a negatively charged particle. You bring near to this charged glass rod and charged ebonite rod which is having negative charge. So what happens when I brought this charged ebonite rod nearer to this charged glass rod? Since they are having unlike charges, they will attract against each other. They will come closer to each other. So here this is a very good example or a simple experimental verification to prove that like charges repel and unlike charges attract each other. Now, this classification of like charges repel and unlike charges attract have many practical applications. In our day-to-day life, we can see this practical applications of this property of charges. What is that property? Like charges repel and unlike charges attract. In electrostatic paint spraying, we are using this property of like charges repel and unlike charges attract. Then powder coating. These are so many examples I can say for this property of like charges repel and unlike charges attract. Third one, fly ash collections in chimneys, Then the fourth one, I can also use this property in inkjet printing. These are the practical applications of the property of the electric charge. Next one, photostat, copying, that is nothing but your Xerox machine. So in all those applications we are going to use what property? The property of charges, that is like charges repel and unlike charges attract. So what are the 5 good examples given in your reader? One is electrostatic paint spraying, second one powder coating, in fly ash collection in chimneys, inkjet printing and in Xerox. In all those we are using the property of like charges repel and unlike charges attract. Then based on this electrostatic behavior of this charges, we can also classify the materials broadly into 2 main categories. So the materials I can classify into 2 main categories based on what property? Based on the electrostatic property. They are classified as conductors and as insulators. Do you know what is meant by conductor? What is a conductor? A conductor is a material which allows the charges to pass through it, whatever may be the charge. If an object allows the charges to pass through it, the object we call it as a conductor. Very good example. Can you say some examples for conductor? Yes? Can you say some examples for conductor? All metals are very good conductors. Then our human body itself is a very good conductor. Earth. These are very good examples for conducting materials. So how I can classify the materials based on this electrostatic property? One as conductor. What is a conductor? A conductor is a material which allow the charges to pass through it. Examples for conductors are all metals and our human body and earth. These are very good examples for conductors. What is an insulator? An insulator is a material which do not allow the charges to flow through it. That materials we call it as insulators or non-conductors. Can you say some examples for insulators? So many examples I can say for insulators. Now we have seen 2 examples now. Glass, wood, ebonite, plastic. So many examples I can say for insulators. Wood, glass, ebonite, plastic, wood. These are very good examples for insulators. So we have broadly classified the materials into 2. One is conductor, the other one is insulators. Then we will go for the basic properties of electric charge. One property we have seen. What is that property? Like charges repel and unlike charges attract. If you go for the basic properties of electric charge, the main 3 properties are, first one is the quantization of electric charge. Quantization of electric charge. Second one, conservation of electric charge. Third one, additive nature of electric charge. First we will see what is meant by quantization of electric charge in the basic properties of studying electric charges. Now first one, the total charge of any system I can find out the total charge of any system is nothing but the integral multiples of the least amount of charge. So, how I can find out the total charge of any system? The symbol for that is Q. It is nothing but the integral multiples of the least amount of charges. Here, what is E here? E is nothing but the fundamental property or fundamental charge carried by the electron. This is nothing but the least amount of charge, which is nothing but the charge carried by the electron, and its magnitude is 1.6 into 10 power minus 19 coulomb, where n is an integer in this. So, I can, in this way I can find out the quantity of charge in a system, in any system. So, Q equal to Ne. What is the unit for the charge? It is coulomb. It is a scalar quantity. Then, conservation of electric charges, second one. So, in this law of conservation of electric charges, as we know, this electric charges can neither be created nor be destroyed. So, from the law of conservation of electric charge, the total charge of any isolated system remains constant. So, what will actually happen is that the charges will be transformed from one system to another system. Anyhow, the total charge of any isolated system remains to be constant. There will be no change in the total system. That is, there will be just transformation of charges from one system to another system. But if you see as a whole, its total charge remains constant in an isolated system. The very good example for this conservation of electric charge. For example, when uranium atomic number 92 and mass number 238, when it decays an alpha particle, it gets transformed into another particle, thorium, with atomic number 90 and mass number 234. Now, I can find out what is the total charge before decay and after decay. So, here this uranium gets decayed by emitting an alpha particle into another element named thorium with atomic number 90 and mass number 234. If you see the total charge of this system, that is for uranium before decay, what is the total amount of charge for this? It is nothing but the atomic number, that is 92E. But after decay, if you see, it is plus 2E plus 90E, isn't it? So, it will be equal to plus 92E. Here it is also 92E. So, if you see the total charge before and after decay, the magnitude is same. If there is any change in the charge before and after decay, there is no change in the charge. The total charge of any isolated system remains to be constant. That we call it as the law of conservation of electric charge. Third one, how to find out the total charge of a system if it contains so many charges. It may be positive charge or it may be a negative charge. If a system contains so many charges, how to find out the total charge of a system? It is nothing but the algebraic sum of the charges present in a system. For example, in a system, there are two charges. Let one charge be minus 2q and let the another charge be plus 5q. Here I have two charges. How to find out the total charge of the system which is having two charges? One charge is minus 2q and the other one is plus 5q. It is given by the algebraic sum of these two charges. So, what is algebraic sum of these two charges? That is minus 2 and plus 5. What is minus 2 and plus 5? It is plus 3q. So, in this way I can find out the total charge of the system. But if a charge contains, if a system contains plus 3q and minus 8q, can you say what is the total charge of this system? What is plus 3 and minus 8? It is minus 5q. So, in this way I can find out the total charge of any system. These are your basic properties of electric charge. One is quantization of electric charge. How to find out the total charge? It is given by the formula Q equal to Ne, where E is the least amount of charge. Its value is nothing but the charge carried by the electron, and it is given by 1.6 into 10 power minus 19 coulomb. Then the second one is conservation of electric charges. Whatever may be that, in an isolated system, the total charge remains to be constant. That is, the charges are transformed from one object from one system to another system. But as a whole, the charges remains to be the same. Then additive nature. How to find out the total charge? It is given by the algebraic sum of the charges present in that system. Then, so far what we have seen what is frictional electricity and the history of frictional electricity, and we have seen the definition for electric charge and how a particle can be charged. In this chapter, we are going to see about how a particle is charged only by friction. That electricity we call it as frictional electricity. And we have seen the history of frictional electricity and two types of charges. One is the positive charge and the negative charge, and very good examples for these two charges. Then what we have seen, the properties of electric charge. First we have seen about the like charges repel and unlike charges attract. Experimental verification also we have seen for this property. Then conductors, insulators. The materials are classified based on this electrostatic behavior of a particle. Then we have seen the basic properties of electric charge. Now, in a system, if two charges are present,